All right, what's on the bench today? All the old timers will know what these are. These are diodes. Yeah, these are diodes. Before they called them diodes, they were rectifiers. Selenium rectifiers. And so, yeah, they look like these cool pagoda things. Sometimes you'll see like stacks and stacks and stacks of them. They'll be like a real Japanese pagoda, like 11-story, you know, kind of thing. And you go, oh, those are just the heat sinks. Well, yeah, that's true. Those are just heat sinks, but there's special stuff in here too. So this is a dual diode. There's 3 connections here, and it's a dual diode. But let's before we talk about these things in particular, I bought them on a surplus site for 25 cents each, brand new. Yeah, nice. So let's talk about what is in these things and what does it mean to be a selenium rectifier, selenium diode. Well, there's plates in here, okay? And these plates are sandwiched together, and then there's a screw that goes between them to hold all those plates together. And so, you know, when you have like a semiconductor, there's layers. There's a P layer and an N layer and different kinds of layers, right? Well, these are layers. It's just mechanically put together. So what's inside this thing? I found this on Wikipedia. All right. So this is the hole, okay? And so this is where the threads are. So it kind of squishes it all together. So you put these things together and you clamp them down. Well, by clamping these things together, you kind of create this contact between these two materials, and you kind of have an area where they kind of act together. So I don't know if they actually heat these things up. I don't know what the manufacturing process is. They may heat these together and infuse some of the two materials together, and they create this junction here. So there's like a metal plate. So this is steel. Okay, so this is the big heatsink thing, and then you've got this slab of selenium, and then on top of that you have maybe some tin and cadmium, okay? All right, so, and then pointed here is the clue, cadmium selenide, okay? So what's so special about cadmium selenide, okay? I've talked about this before on the channel, but let's go look at the periodic table with Time for Science. So semiconductors like silicon and germanium have properties, and the properties these atoms have is how many external or valence electrons do they have. So you have core electrons, and then you have a few spinning around on the outside. They're kind of up for grabs. And so silicon and germanium have 4. So this is the 4 column. So so you can make semiconductors out of these four valence electrons devices. Now you could also make a combo, okay? You could take gallium and arsenide and put those together. One of them is a 5 and one of them is a 3, and when you add them together, they end up being a 4. So gallium arsenide is great for LEDs, for like IR sensors, indium antimony. And you can make tertiary ones as well, but yeah, there's all kinds of things you can do. So blue LEDs are gallium nitride. So you take a 2 and a 5 and you get a 4. Okay, so what do we have? We have cadmium selenide. Cadmium selenide, okay. Well, selenium is here. Selenium is a 6, okay. And if you want to do that combo thing, you need to add a 2 and a 6 together to get a 4. So let's go over to this 2 column. And look, cadmium's in the 2 column. So cadmium selenide, add those together, you get a semiconductor. Or zinc selenide, that's a famous one. Zinc selenide is a semiconductor, okay? So that is the way that the semiconductor is created. It's this cadmium selenide that's the actual diode. So is it a selenium rectifier or is it a cad selenide rectifier? I think it's a cad selenide rectifier. Anyway, they call them selenium. All right, so what about these guys here? These guys are I said 2 diodes. No. Let's see. I'm trying to remember how these go now. Yeah. They go like this. Okay, so this is the device. It has 2 anodes and one cathode. So that's how these are. And I think the thing to do is let's see if they're a real diode. Okay. Get out our diode checker. I think this one. Oh, I can't put it in there. Never mind. We'll use this one. All right. So let's see here. Let's hook up a couple wires here. Wire on that one. A wire on this one. Yeah, push the button, and it says it is a diode. At 10 microamps, it is 0.342 millivolts. I mean volts, right? 0.3 volts. And then let's check the other diode. It's over here. Do that one. And yes, indeed, it is 0.358 volts. All right, so they are diodes. All right. So what do you do with diodes? Well, most of the time you use them for power supplies and stuff. I don't think this one was. So most of the time you see selenium rectifiers, they're in power supplies, okay? And they're pretty high current because back in the days of tube radios, those things ate a lot of power. And so the diodes in a full bridge rectifier in an old tube radio, you would have a pretty big stack of plates here to do the work. And you needed 4 diodes, right? So you need at least twice as much as this to have 4 diodes. But I think this one is kind of what would be a small signal selenium. I couldn't find the actual, so the part number on this one is a 22S33-1C1-ZS. And I couldn't find the exact part number. I looked at a bunch of old catalogs for, you can find them online, Selenium Rectifier catalogs. They actually build these things still, believe it or not, in India. But I believe this is a 65 milliamp diode. Yeah, 65 milliamps. And so let's go ahead and put it on the curve tracer and see what we see. All right, let's take a look at a 1N4001. That's a pretty generic device. I'll turn the brightness down a little bit. All right. So it has 100 millivolts per horizontal and 10 milliamps per vertical. So 100 milliamps up at the top. And so let's see here, 10 milliamps. 20, 30, 40, 50 milliamps. We're at about 0.75 volts, something like that. So that sounds pretty typical for a power diode. All right, so let's take a look at a selenium rectifier, and whoa, look at this. Look at this. So it's already starting to shift. I think some of these are only good for 36 milliamps. I'm not sure what these parts, I couldn't find a data sheet for these parts, but we'll run up to 50 here because it doesn't stay there very long. It's sweeping. So you can see that even though it's starting to turn on sooner, remember this one didn't turn on until way out here at 0.6 volts. This one is turning on much, much faster, but then turns into a resistor, okay? I've seen, I'm gonna see if I can find it. There are circuits to replace selenium rectifiers with normal diodes, normal silicon diodes. And it includes having a resistor in there to mimic this curve, okay? So it probably looks something like a Schottky diode with a resistor on it. And so yeah, you get this super, super straight line here. So then it starts to bend a little bit as I turn it up. I'm thinking it's probably the junction is heating up, so I don't want to go too far up in that direction. So we'll keep it right here. Let's jot down some numbers from this, and then we can do the calculation of what the value of that resistor is. All right, I jotted down some numbers. Remember, we had a curve, right? And so I took 2 points on the curve that were along this straight line. I had 0.38 volts at 10 milliamps and 0.58 volts at 50 milliamps. So if we do some math here, okay, so we're changing 2 volts here, and we're changing 40 milliamps over here, okay? So we have rise over run, right? So this is rise over run. Volts equals IR, okay? So R equals volts divided by I, which is 0.2 divided by 40 milliamps, which is calculator time, because I'm lazy. All right, so we have 0.2 volts, 0.04 milliamps, 5 ohms. 5 ohms. Okay, so let's build a fake selenium. We learned that maybe 5 ohms was pretty good, and the turn-on voltage was kind of like a Schottky diode. So if we take a Schottky diode, how do you make a Schottky diode? I'm going to put an S here for Schottky diode. And if you then put in a 5 ohm resistor, I claim this is the equivalent. So let's go. Is that on camera? Sorry. A little bit low, so we will take this. I'm just going to use a BAS25 Schottky diode, and we will put this into the curve tracer and compare the real selenium with the fake selenium. All right, this is our selenium rectifier. And remember, comparing that to a 1N4000, right? These look completely different, right? So let's go ahead and put in my fake selenium rectifier. Let's see, I think he goes in like this. Yeah, look at that. That's not too bad, huh? So that's the selenium, and then this is the Schottky plus 5.1 ohms. Yeah, so not too bad. I think you could substitute those two. All right, that seemed to be good. So you can go online and you can look at a bunch of people who have replaced the big power seleniums in circuits. And this 5 ohm resistor ends up being about a 50 ohm or 150 ohms, depending on the circuit that's used in the radio and how much current and everything. And obviously you would use like a 1N4000 here instead of this. So these high power ones are higher voltage. They're more leaky because you're putting a lot of current through them. So when you simulate them, it's better to have either a 50 ohm or 100, somewhere between 50 and 150 ohms, and depending on your application. So you can go online and search that if you care. I think there's even some YouTube videos on old timers fixing up tube radios. I'm no expert on that. I just wanted to play with some rectifiers that I found at a junk store. 25 cents, seems like a lot of fun. I think, let's open one up, see what it looks like inside. All right, let's put a wrench on this and screwdriver on this side and see if it comes apart. Yes, it does. They're always painted, so I think there's some problems with moisture. So they probably put the paint on to seal out moisture. That's just a guess. They're always painted. Okay, so we have, I'll keep the screw on for right now. So we have a couple washers. We have a flat washer and a lock washer. And then we have this first thing here. Let's see, I don't want to keep these in order. All right, so what's first to come out here? Okay. Oh. Okay, there's this thing, which looks like just a piece of steel. So that just looks like steel. And then there's kind of a compression thing here, and then that's the diode. So well, we're missing the diode. The diode's in there somewhere. All right, because this is the center conductor, and then this is the other diode on this side. So this is one diode, and this is the other diode. Let's check that. Looks like there's some funny business going on there. That might be the magic. Okay, so we're going to put this connector here, and I will hold this onto that center thing there. And nope, that says that's not a diode. Ah, that's a diode. Ah, interesting. Okay, I don't know if you saw what I did there, but I put my probe on this shiny metal here, and that didn't work. And then I put my probe on this ugly part here, and that did work. So this little compression washer makes contact to this piece, and then I was making contact to the center, which I suppose is that. Ah, okay. Let's do that. So I think I need 6 hands to do this. I'm going to put one here and one here. You see what I'm doing there? One on that middle contact and one on the outer contact. Can I do it? Can I do it fast enough? All right. Diode checker requires I have not got 2 hands loose. All right, so here to here, not a diode. Here to here, diode? No. Oh, there we go, diode. To here, no diode. To here, diode. Ah, I'm touching. Yeah, there's something strange about this silvery thing here. Either I'm just not getting through it. No, it's insulative. If I reach inside and touch the inside of that ring, then it's a diode. And it's short there. Yeah, diode here, 0.3 volts. Very interesting. All right, so I'm very confused now. I would have thought it would look much different than this. It seems to be kind of all centered together. Yeah, I think it's centered together. Some magic I don't know. All right, comment below if you know how these things are manufactured. This is really weird. Huh. All right, well, there's a diode. That's a diode right there. All in one plate. I would have thought this was just the heat spreader, but nope. Nope. It's all centered together in some magical furnace with magical components, and it makes a diode. And does it in concentric circles of some nature. 2.4 volts. Did I just ruin it? Oh, there we go. 0.3. 0.3 in that direction, reverse direction. Oh, we didn't look at the reverse characteristics of a selenium. Oh, we need to do that now. All right, here's the forward characteristics. Yeah, let's look at the reverse characteristics. Okay. I changed my scale here to 1 volt, 2, and milliamps. Let's go to 100 microamps for fun. Oh, yeah, that's not good. Yeah, they're kind of leaky. Oh, they're very capacitive too. Ooh, look at that. Phew. So circles are capacitors in this tester here. Make sure that we're, yeah. Oh, that's really weird. All right, let's do the scale. 1 milliamp. Yeah, 1 milliamp. Let's see, 1 volt, 2 volts, 3 volts, 4 volts, 5 volts, 6 volts, 7 volts. So 7 volts, it's leaky 1 milliamp in the reverse direction, and it's very capacitive. Wow, this is really weird. Yeah, selenium in the backwards direction. Let's go ahead and go to, that's too much. 5 volts, 5 volts. 10 volts, Look at that. Look at that reverse breakdown. Wow. Not very good diodes, are they? That's why seleniums aren't around anymore. Oh, all right. That's really cool. All right. This video is probably several decades too late, but it's still fun for me. Hope you learned something. Yeah, these are cool.